Hi and welcome to John's Maths Book. In this video, we're going to be looking at deriving the formula for the volume of a sphere using integration. If you like the video, then please hit the like button and I'd be delighted and honored if you'd subscribe to the channel. Without further ado, let's go over to the whiteboard. If we take a sphere in 2 dimensions and place it on an XY axis, it looks like a circle with radius r. The sphere is made up of an infinitesimal number of circles within. Here are some that I've drawn on the diagram. The radius of each of the circles, as shown here, is equal to y, as that's the distance from the x-axis to the point at which it reaches the sphere. Now we know the area of a circle is given by pi r squared, where r is the radius of the circle. So for each of our internal circles, the area can be given by pi y squared, as we've determined that y is the radius of each of the internal circles. So if we now express this in terms of the radius r of the sphere, as this radius doesn't change, we can do this by creating a triangle here. It's a right angle triangle, and the hypotenuse side is given as r, the radius of the sphere, and we have a side of y and a side of x. So if we use Pythagoras' theorem, we have y squared plus x squared is equal to r squared. So y squared is equal to r squared minus x squared, and therefore y is equal to plus or minus the square root of r squared minus x squared. If we now substitute for y in the area formula, we get the area is equal to pi times the square root of r squared minus x squared squared, which equals pi times r squared minus x squared. Now, to get the volume of the sphere, we need to sum up all these circles. We do that by integrating. So the volume of the sphere, V, is the integral from x equals minus r to x equals r of pi multiplied into r squared minus x squared by dx. If we now work out this integral, let's first remove pi outside the integral to give pi into the integral from minus r to r of r squared minus x squared dx. If we integrate this, we get pi into integrating r squared, we get x r squared minus, and the integral of x squared is x cubed divided by 3, and that's from minus r to r. So when we put our values of r and minus r in, we get our volume is equal to, so plugging in r, we get r cubed minus r cubed divided by 3, and that's multiplied by pi, of course, minus pi multiplied into, and if we put our negative r in, we get minus r cubed minus r cubed divided by 3. So this gives us 2 pi r cubed divided by 3 minus pi multiplied into minus r cubed plus r cubed divided by 3, which in turn gives us 2 pi r cubed divided by 3 minus pi multiplied by minus 2/3 r cubed. So this gives us 2 pi r cubed over 3 plus 2 pi r cubed over 3, which is equal to 4/3 pi r cubed, which is equal to the volume of a sphere.